Hi, good morning, good afternoon. My name is Marco Pierobon, and I'll be your guest speaker for today. Before we start with the presentation, a little bit of context. This talk was initially given at XConf Europe, a conference organized by Thoughtworks. It's our tech conference, which is done by technologists for technologists. It took place in Barcelona in September. It was a fantastic experience in a terrific venue where we met very, very interesting people talking about tech, business, and even less formal topics. For those who could not join the event on site, we are now repeating some of our talks with a LinkedIn live webinar, so you can catch up with the content and feel the XConf vibes. We ask you to kindly use the comment function below to ask your questions. All questions will be answered in real time after the talk. In case there will be no time for answering all the questions, we will reply to them afterwards via reply to your comments. So without further ado, let's get rolling. So my name is Marco Pierobon. I'm an Italian developer who's based in southern Spain. I've been in Thoughtworks for almost 4 years. During my spare time, I like to train, spend time with my dogs, and defend animal rights. Thoughtworks' purpose is to drive impact in the world through our culture and technology. We have a very long and incredible track record when it comes to drive innovation. So we created the first CI tool back in the days. We invented a tool that some of you are most likely familiar with, like Selenium, and we created and then spread the technology radar, where we collect the feedback from all the thought workers working in a disparate set of projects and technologies, and then we do our recommendation on where the market is going. We also have over 100 books written on any topic that ranges from very deeply technical one to how you can implement Agile in your organization, how you can have implement digital transformation, DevOps. So when you're looking for experts, there's no better place to look for than Thoughtworks. Starting with the agenda for the day, we'll first have an introduction about developer productivity. We'll look at the good practices on how that can be measured, and then what bad practices are, and finally, what data is telling us about it. So as an introduction, we can start with some notions. You can read them all by yourself. I was told that I shouldn't be reading quotes in my presentation, so I won't be doing it. The one exception is the one at the bottom right, where we need to clarify that by developer productivity, we mean the degree upon which developers can do their work without being constantly blocked or in a frictionless manner. But we are not taking into consideration the individual performance of a developer. We then need to look at 4 key elements: input effort, output, outcomes, and impacts. They are usually confused, and most often we are chasing the wrong ones. So by input and effort, we mean how much time, thought, creativity, just maybe even energy we spend into development activities, which could be designing, coding, testing, debugging, maintaining a software product. Outputs, on the other hand, are tangible things that are delivered as a result of the inputs we just described. An example here could be a piece of code, a new feature, or a new page in the documentation. Outcomes instead are the changes that are driven by the response to those inputs and outputs we just illustrated. Example of outcomes can be a change in a business process, a change in a client behavior. Finally, impacts are the values that are delivered to the business. An example of an impact could be an increase in sales or an increase in efficiency. So when we want to look at good measures of developer productivity, what should we focus on? We should focus on impacts and quality. We can consider outcomes and impacts rather than input and outputs. We can track the delivery speed using outcomes that are tailored to the customer needs. So how it affects our customers. We can then define productivity as the amount of value delivered over a unit of time. And if we extend this measure over a significant period, we can see how it improves or if it doesn't improve, and then take measures accordingly. If these measures is kept consistent across teams, we can even compare the productivity of different teams. But that's not always the case. So this can lead to scenarios where we are trying to compare different teams, but using different measures. And of course, this will yield very misleading results. When we look at the developer productivity, it's important to use data. So we have a set of metrics that can help us, guide us in this space. The most cited one is most likely DORA, where we are tracking how often we deliver, and for instance, how much time passes between two failures, plus a few others. And we have some indicator of how good our productivity is. The problem with this is that it provides only one angle, which is the quantitative side, and we'd much rather combine them with qualitative measures, meaning that we also have input from the customer development team that are not based on automatic calculation, but on impression, feelings, and direct feedback. Other set of metrics that are common and very effective are space, and the one that was designed within Thoughtworks is EEBO, which provide a line of sight between technology and the business. So why is it important to combine qualitative and quantitative metrics? As an example, when we don't feel good and we go to the doctor, we tell to the doctor that we don't feel good. So the doctor proceeds in taking our blood pressure, checks our heart rate, our temperature, and then the doctor could say, well, looks like you're all good. There's really nothing wrong with you. How would we feel if we still feel sick? So all the data measures we are given are fine, but we are still not good. So there is something that numbers alone cannot tell us. That's why we need to combine those two very different viewpoints. And it's important to not pitting qualitative and quantitative metrics against each other, because the qualitative metrics can help us have a more holistic view and a more holistic context, while quantitative metrics are very reliable and very specific, but they only tackle a narrower set within the software delivery process. When we look at measuring the productivity of a team, we are getting better numbers, better fidelity, better accuracy, because we are not looking at individuals. If we try to score one developer versus another, it's going to become very, very difficult to know who's more effective, who's developing more code, who's providing more value. If we start looking at the team level, those numbers start becoming a bit more reliable. Why is that? By nature, the software development process is a collaborative effort. So by fostering an environment where a developer knows that he or she is being ranked by how much code they produce, how many story points, you are removing the collaboration out of the teamwork. So are you really improving the team effectiveness then? Or are you optimizing for a local optima, a concept upon which we'll return later on? It's more important to focus on the work-life balance to reduce the stress the employees have and provide physical and mental health to the team members. It's important to spend a substantial amount of money, the necessary amount of money, on getting the best and necessary tools and processes so that teams don't need to do a lot of manual operation that can be tedious and error prone. And they can also be guided, for instance, by AI, a topic that is quite recurring nowadays, or can have automation in place so that they don't need to redo the same manual operation over and over again. So we discussed what are some good practices when it comes to analyzing and inferring developer productivity. But out there in the wild, we've seen also some pretty bad practices, and here are some of them. We've seen companies focusing on inputs, outputs, or efforts rather than the impact they have. We've also seen that if we try to measure the productivity of a single developer, we lose their trust. We are building an environment in which the developer feels imprisoned, where they are forced to work in a certain way, trying to maximize a measure that doesn't allow them to express their creativity or their skills. And developers can be quite smart. They are able to game the system. So if you optimize for number of commits, you're gonna get 1,000,000 commits. If you optimize for story points, you're gonna get very big stories. If you optimize for number of lines, you're gonna get very big files and very big pull requests. There's also the misconception that developers should be focusing on coding 70% of the time. We mentioned earlier how collaborative software development is by nature. So if you prescribe how much time developers should be coding, you are essentially removing their capacity to collaborate, to flag when there's an impediment, when there's a dependency, and in the long run, you're going to lose that capacity for developers to chime in the development process and make it better. If we start introducing those measures of individual performance, the developers will manipulate the system. They will try to cheat so that they are, if not ranked first, they're not ranked at the bottom. Because another consequence of focusing on individual performance is giving rewards and promoting the best contributors, but also punish the ones at the bottom. And nobody wants to be last. So if somebody's last, they will work very hard to not be last, but this will not improve the productivity of the team. They will just improve a metric, which in the end is not even tied to the quality of the delivery or the frequency of the delivery or the value to the customer. And this is because a software development team is not a group of individuals, developers working alone, but the work of a team member is a function of the output from another team member. Plus, we have a lot of interactions that happen during the day that cannot be measured. We can imagine, for instance, a senior developer in a team spending 60 or 70% of his days during designs, doing code reviews, investigating issues in production. All those activities might not show up in a scoreboard, but those are invaluable. If you start fostering an environment in which these activities are not rewarded, people will just stop focusing on them. We just focus on writing as much code as possible with the consequences we can imagine. We've seen also some companies that want to have metrics for the sake of having metrics. So having a flashy TV where we have the developers by number of story points, by number of close merge requests. It's something we can call a vanity metric. This is also something that is implied by having a command and control mindset, where we have the tech leads, the engineering managers that are telling the developers what to do, and the developers should just read the ticket, implement it, and deploy it, and just go home. We know in reality how difficult it is to work in software, and there are very, very few occasions where you can just read the specs and implement them without any need for additional collaboration, without reaching out for a question for a merge request review, or just simply to double check a business logic situation that you haven't experienced yet or that you are unsure about. So again, in this scenario, you're not putting the human as intended as a developer at the center of your metrics. You are just using them as a tool. Also, you're not factoring in qualitative data. In a scenario like this, we would also be losing focus on some key aspects, such as having an efficient workflows, So if we think, for instance, the time it takes to get some code shipped to production, also referred to as lead time, if we don't prioritize improving it, or if we don't highlight when that starts becoming a problem, we just focus on those metrics, those vanity metrics, where people can just push code and be ranked higher. But if somebody wants to tackle one of those inefficient workflows, they get penalized, or if somebody tackles a tech debt that has been lingering there for years and is making the code less maintainable, is making code evolution much harder, is making the systems lower, is making perhaps just the cloud cost going much higher without a need for it, people will not do it because it's not being rewarded. How do we take care of the documentation? If the documentation is not something we focus on and we measure, but we actually measure only the amount of code being deployed or being written, somebody who focuses on documentation will just be scored lower. So there's no motivation for a developer to focus on that. So now we saw a few examples of what companies are doing out there, but those could just be my impression, what I would recommend doing and what I would recommend not doing. But luckily, we also have some data that will help us make a more informed decision. So if we have a healthy culture or a generative culture in our organization, we see that that has a strong impact in the team, organization, and operational performance. The same for software delivery performance, for the efficiency of continuous integration and continuous deployment. It will increase dramatically job satisfaction and productivity and reduce dramatically burnout. So there's a strong correlation. As one measure increases, the other one also increases. What is a good generative culture? This is a culture in which the leaders set up a vision for the company or for the teams, and then they get out of the way. They let the individual contributors drive those technical capabilities that are able to improve the performance, but they're not dictated by the leaders. What are the benefits? A generative culture favors outcome, cooperation, and the whole team or company over the outputs. It's also shown that teams that use a generative culture have a 30% higher organizational performance than teams without. So it's definitely something we can look into. When we are building a new product, service, or software, we don't always start with the user in mind. We might believe we understand the users. We might believe we are the users, but if we don't focus really on what the users want, we can see some significant performance penalties. So when a team has a strong user focus, this yields a 40% higher organizational performance. It also shows as a 20% higher job satisfaction for the developers working in this way. It's strongly correlated with team performance and productivity. What's required for this? It requires that all product, operation, and platform teams think of the user, of course, at different levels. Platform teams have development teams as the users. The same can be said for operation teams, but product teams have end users that they are building their application for, so they need to understand and know them, which very often can signify spending time with them. Developers, not all developers like human contact, but forcing them to do it can actually make them appreciate their job more, which sounds a little bit counterintuitive. One of the most recurring pain points when it comes to software development is the time it takes to get your code reviewed. So the longer you wait, or the longer you need to wait for your code to be reviewed, the more context switching you need to do, because you might think or might be asked to start on another story, and then you need to switch between branches, or you might just sit idle and then not feel productive for the entire sprint or for the entire cycle because you haven't contributed enough. But also it can lead to more tangible problems like having more merge conflicts when you want to review your stale code because somebody else merged while you are waiting. And just solving those merge conflicts can be very frustrating and very tedious, and it can also introduce additional bugs that were not needed. So by increasing the code review speed, you also obtain a strong improvement in the delivery and operational performance and a strong decrease in burnout. Now, if you have a single code base or a monolith, it becomes more common to have a lot more people working in a single repo, which means that the code reviews might or might not take longer, but will most likely result in some merge conflicts. So this is usually solved by using loosely coupled architecture sometimes referred to as a microservice architecture. And the data shows that using these types of architecture is strongly correlated with team and organizational performance, and strongly inversely correlated with burnout. The data we have so far is not strongly in favor of AI. It's slightly positively correlated with individual well-being improvement, but as a group level measures, the data is still unclear. One number as a takeaway, those teams that have shorter code review times end up having a 50% better software delivery performance. So if you want to improve one thing out of this talk, this is a very good starting point. So if we want to look at individual measures, what should we look at? It's important to look at those measures about the job satisfaction and how a developer feels productive. So those are not quantitative ones where we measure them based on numbers, but they're usually handed out as surveys. So we ask developers how satisfied they feel with the work they're doing, with the business they're in, with the technology they're using, and with the people they work with. And we track patterns, because usually it's quite common to see the developers within the same team organization answer in a consistent manner, and tackling those issues can lead to big improvements in the company at large. Other things to take into consideration is that if we improve the documentation in a team that is using trunk-based development, where we are committing directly to master, we don't create pull requests or merge requests, which is one potential issue that we just discussed. Having those excellent documentation leads to a 12-fold performance increase. Another important aspect is how reliable our software is. So once we start a new product or a new application, we might think that being in production, maintaining live users doesn't need to be a concern from day one. So we might think about postponing it until later on. Of course, this starts becoming a daunting problem once we do have those users on the live environment. And we see that increasing reliability, just even at a small scale, yields tremendous operational performance improvements, which means that we are spending a lot less time maintaining the system. We're spending a lot less time investigating strange issues that are difficult to reproduce, so that our development team can actually focus on new work. A common pattern is that when teams or organizations start investing in this area, the initial return on investment can be a little bit slow to show up. So it's very important to stick it out through the initial phase until you start seeing the results, because from the initial lull, from the initial difficult part, once that is sorted out, it's going to get an exponential effect. How can this be achieved? We need to aim at reducing toil, having blameless postmortems. So every time there's a production incident, having all the developers involved in the project together, understand the 5 whys, understand why it happened, why it ended up being like that. So we end up identifying the underlying cause to the outage, which most often ends up being a manual operation that wasn't automated because it was very easy, or because there wasn't time, or because it seemed very long to implement. But then, of course, a production incident is much more costly. It's also shown that there's a nonlinear relationship. Here we can read it as exponential between operational performance and practices such as automation. So the moment you start automating your code shipping, so you start having automated infrastructure deployment, package management, delivery management, you start seeing exponential improvements in your operational performance. Talking about automation is a good segue to start talking about the cloud. The cloud has been all hype for the last 10 or even more so years. Everybody wants to move to the cloud, but the data shows that there's no significant difference between public or private cloud, but the actual difference is in the use of flexible infrastructure. So if you are able to spin up new infrastructure automatically, if you are able to scale up and down, and if you are able to run experiments on a whim, so we don't need to go through procurement to buy new servers or to get an approval from finance to test something new, this yields massive performance improvements. Another point to focus on is a fair distribution of work. Something that we've seen quite often is that some teams prefer to assign the work preemptively. So whenever there's a sprint planning or an iteration planning, some people prefer to assign the work to their team members because maybe they think that a person is more well-versed in the front end on the database or the cloud infrastructure. But this doesn't factor in like what an individual would like to focus on. So even if I'm perhaps very good in front-end development, I would like to start focusing on the cloud or start focusing on the AI tools we started building or we started using, but I've never given the chance. So being able to have a fair distribution of work, which to be fair, the simple way to achieve would be to just let people choose their own work, can lead to significant performance improvement. And this goes, again, alongside an improvement in the quality of the documentation. It also eliminates the burnout, the difference in burnout across genders. So if the person assigning the work is of a different gender than the people being assigned to, this can cause even more friction. If you let people choose the work they prefer, the difference is gone. Another important aspect is focusing on the developer experience. With developer experience, we mean the set of tools, practices, and operationals, common patterns that we use internally to start a new project, start a new service, a new repo, and getting it shipped. Of course, once we look at how a company does it, it ranges dramatically from every new service or every new repo has to do everything from scratch. So creating a new pipeline, creating a new guideline for how the code should be written, creating a new integration with the artifact repository, creating manually the infrastructure on the cloud, or it could just be using a template, cloning the template, changing a few variable names, and you have everything ready in half an hour. We've seen both cases and a lot of variety in between. So how do we increase developer productivity in this context? We can do it by setting clear goals for the project. So knowing what developers focusing on the developer productivity should aim at, which again ties to knowing your users, because a developer experience team is serving developer teams as the users, and promoting psychological safety. Having a good developer experience helps with improving the productivity, satisfaction, engagement, and even the employee retention. So this is definitely an area worth investing on. If we then look at the team level, it increases the productivity, satisfaction, engagement, and again, employee retention. While at the org level, it improves build and delivery times. It improves the management of complex infrastructure where we might have dependencies across teams. And also it allows for self-service, whereby a team can spin up a new service without having to reach out to a platform team, for instance, or having to wait for another team to do things for them. Here, it's very important to have the developers feeding their experience, feeding their pain points to the developer experience team, and making sure that they are improving the next release. So we covered a lot of ground today. We saw the difference between the good practices, the bad practices, what the data is telling us about them. And we saw how a combination of qualitative and quantitative metrics can help us really get a good sense of how our productivity is and how to improve it over time. It's very important to focus on the global optimum. What we want is to improve the delivery efficiency or the productivity of the organization at large. If we focus on the productivity of a single team, we are not getting the results we wanted. For instance, if we focus only on the productivity of the developer experience team, but we don't focus on the productivity of the product teams, then ultimately what we ship to the market is going to take much longer and it's going to have lower quality. Even more so, if we try to optimize the performance of a single developer, we are losing track of what it means to optimize the performance at large. So we are using vanity metrics that can look good and can give us a feel of improvement over time, but that's not what we should be aiming at. So how do we select the right metrics? There's no one size fits all solution, unfortunately. But as an example, we can start by thinking at which signals we want to look out for. Those signals can be how easy, how quickly, and with what quality. Of course, referring to the code the developer experience team is producing, the service the development team is producing. How easy do we want it to be for then the product teams to use it? Or how quickly do we want it to be delivered? We can then select a metric for each category. So for instance, for speed, we can combine qualitative and quantitative metrics. We can use perceived delivery speed and perceived productivity. Then for ease, we can combine qualitative and quantitative metrics with ease of delivery, deployment lead time, and build failure rate, where of course ease of delivery is qualitative, where we can send a survey to the product teams, and deployment lead time and build failure rate are quantitative metrics that we can infer from our CI/CD system. And for quality, we could look at, for instance, at the incident frequency and the perceived software quality. Again, first a quantitative metric and then a qualitative one. We can finally add some operational metrics, such as the developer satisfaction with a given tool we are providing or the adoption rate of a particular service. Again, a combination of qualitative and quantitative metrics. Adoption rate can be measured either way, and potentially a combination of the two is useful. But this is it. So thank you so much for joining. Here you have a QR code to give me feedback on the talk. And we're going to share the slides with you where you have a lot of reference materials, starting with the articles that we used as a source for the presentation, and then a few examples of the metrics that you can use. So this talk will be available here on LinkedIn, as well as on the XConf Europe playlist, alongside all the other talks from this year conference. In the chat, the link will be shared with you. If you want to know more about XConf or listen to more talks from the conference, you can check out our XConf website. Again, it will be shared with you. We hope to see you at another event soon, hopefully at XConf Europe 2025. I don't know where it will be, so I can't tell you yet. Stay tuned for more info by following our LinkedIn page. So I think now it's time for some questions, if there are any. So what was the name of the developer productivity framework produced by Thoughtworks? It was EEBO. You can find more about it on the Thoughtworks page. Then a question from Roberto. How do you nudge divergence from vision? Teams delivering shortcuts instead of vision core. How often to provide feedback guidance? Excellent question. So this is one of those examples where if you only focus on quantitative metrics, you can cheat the system. You can say, our numbers look amazing. We are going to production 25 times a day or 1,000 times a day. We never have a failure. If there's a failure, in 5 seconds, we are already operational, but they're not providing value. So it's important to combine the business values you are driving with each single change with how often you are able to ship that change. And this is something that, for instance, Space and EEBO can do because they combine those qualitative and quantitative metrics, which is something that the DORA framework, for instance, cannot do. No more questions. Fantastic. So thank you so much for joining. It's been a pleasure having you here. All the information we discussed earlier will be shared with you in the chat, and I hope to see you next time.